This is actually the video for writing the equations of a cubic, but this, I know it says quadratic, and it's not a mistake. I really wanted to relate this to what we just did not that long ago with quadratics. So when it was a quadratic, notice that I had two sets of parentheses as given two intercepts and some point x and y. Y value of 5, a value I don't know. We've got a p of 3, so minus 3, and another p value of 1. It's a plus 1 because remember it's a minus with that negative 1. And the x value of 1 we'll use twice. I'm going to go through, simplify what I have in parentheses, so that's a negative 2, positive 2, so I got negative 4a equals 5. So a little division, negative 5/4. So when I go back to write my equation, I've got y is equal to negative 5 over 4 x minus 3 x plus 1. And that's how you write the equation of a quadratic equation in intercept form. Well, a cubic isn't all that different. We just took 3 points, 2 intercepts, and a point that's on the graph to write a parabola. In the past, we needed 2 points to write a line. It takes 4 points to write an equation in cubic equation or cubic form. So what I'm just going to do is basically take that same intercept form and go a x minus p x minus q, but I'm going to add one more set of parentheses, and I'll make it r just for my third intercept. So I need this value, which looks like it's negative 4, this value, negative 1, and 3. So that's going to be my 3 intercepts. I'm just going to substitute in. And the reason why they're plus, actually, even because they're negative, again, is because it's a minus and negative 4, and it's minus and negative 1. Again, the minuses are part of the formula, so oops, I forgot my minus there. And I'm going to take this point of negative 2 comma 1. So here's a y value, 1, and here's the x value of negative 2 that you'll see 3 times. Okay, so again, I'm going to go through, simplify my parentheses. Sorry, that's not 4, that's going to be 2. Negative 1, negative 5. So 1 equals 2 times negative 1, negative 2 times the negative, that's going to be 10a. Divide by 10, and my a value is 1/10. Okay, now this is a positive a value, so if I go back to what we talked about with n behavior, for a cubic, if I have a is bigger than 0, so it's positive, on this side it should be going down and up. Well, since my graph was going down on the left side and up on the right side, my a value needed to be positive. So if I go back and I write my equation in intercept form, it would be y is equal to 1/10 x plus 4 x plus 1 and x minus 3. And there we go. If I wanted to put that into standard form, what I would do, so if I want standard form, I'm just going to go through and FOIL / distribute all of that stuff. Now, because of the 1/10, I'm not going to make you do it on this particular one, but just kind of know that that's the idea, how to go from intercept form to standard form. Okay, same situation here. You want to make sure that you grab your 3 x intercepts. If there aren't 3 x intercepts, we're going to have a tough time pulling off this cubic in intercept form. Let's see. I mean, there are some cubics that won't touch the x-axis 3 times. 1, 2, 3, 4. Okay. Take my point. Again, it doesn't need to be this point. I'm just picking this point because it's a nice whole numbered point. So y is for... let's see. So again, y equals a x minus p, there's one intercept, x minus q, there's a second intercept, and x minus r, there's a third intercept. And the reason why there's 3 intercepts is because I have x to the third power because it's a cubic. So 4 equals a 0 minus a negative 2, so plus 2, 0 minus 2, and 0 minus 4. So 4 equals, that's going to be 2, negative 2, negative 4. I think the biggest issue I ever see is those 3 need to get multiplied, and they're going to give you a positive 16a. Again, my end behavior is down on the left side, up on the right side. I know that my a has got to be bigger than 0, and when I get this, I have a fraction of 1/4. Yeah, good. That's what it should be. So, in intercept form, my a value that I just found, I have my x. I go back and I put my 3 x-intercepts in there, and that's my graph in intercept form. Again, if I wanted to do it in standard form, and maybe I will with this one, okay? So to put this guy into standard form, what I'm going to do is I'm going to take 2 of them, FOIL them, and I get x squared minus 4, okay? Because if I go x squared minus 2x plus 2x minus 4, those middle 2 are going to cancel out. I'm going to distribute here. I got x to the third minus 4x to the second minus 4x plus 16. It's a sloppy 16. And then I'm going to multiply them all by 1/4. So 1/4 x to the third. 1/4 times a negative 4 is negative 1 x to the second. 1/4 times 4 is a negative 1 again, so negative x. And 16 divided by 4, or 1/4 of 16, is plus 4. And that would be here in standard form. Okay. Again, that one wasn't so bad. The last one with the 1/10, that might get a little bit tricky and a little bit ugly, but with the 1/4, it's not as bad. Okay, if they're not on the graph, same thing. I know that the 3 x-intercepts are right here. But if that's not something that you can visually see, go to a graph. There's 0, 0, 1, 2, 3. There's another one. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's another one. I have 1 and up 4. Now, it's kind of tricky thinking about end behavior if they just give you the points and just forward the points, because there's a lot of curves that go into a parabola. I don't know if it's going up this way and down and whatnot. So here's my x, here's my y. So 4 equals a 1 minus 0, 1 minus 3, and 1 minus 9. So 1, negative 2, negative 8. Hey, guess what? 16 divided by 16. I get the same a value did the last time. So y equals 1/4. Now, I don't really have to put x minus 0, but here, I'll start off with that. X minus 3 and x minus 9. You might see that one right there is just x, because, you know, x minus 0 is x. So there you go. There is solving, or not solving, there is writing the equation of a cubic in intercept form, a lot like what it would have been for a quadratic.